Since the 1980s, Midwest Optical Systems has designed and manufactured high-quality optical filters for industrial imaging. From our humble beginnings with a single red machine vision filter in our Singapore office, we quickly expanded to North America and have grown to offer one of the most complete lines of machine vision filters in the world. Machine vision is typically defined as automatic imaging-based analysis for industrial manufacturing applications. It originated in the 1930s, but its employment has grown exponentially since the 1970s as new supporting technologies emerged. In more recent years, machine vision has become widely employed as a means of conducting automatic inspection, process control, and robotic guidance to efficiently and effectively see product defects, sort products, and identify features and anomalies of subjects being inspected. This helps streamline production, improve quality control, and works to scale overall output of the manufacturing process. The utilization of machine vision-specific LED lighting essentially began to take off in the early to mid-1990s. LED lighting addressed many of the problems concerning the cost and variability of other lighting options, be they ambient or purpose-built, that were more traditionally used to illuminate inspection and other manufacturing operations. By the 1990s, LED lighting designed for machine vision primarily used LEDs with output centered at or near 660 nanometers. These LEDs were inexpensive, readily available, and bright when compared to other LED colors. Despite the advantages, vision applications using LED lighting tended to be more light-starved. The traditional method of overcoming this problem was to turn off ambient lighting, which was not always practical, or shroud the application to block interference from outside light. However, shrouds tend to be costly and time-consuming to design and build, and often can be difficult to work around. Instead of shrouding, the concept of blocking ambient light by filtering the light entering the camera lens gradually became more widely adopted. MidOpt recognized that instead of using a red photographic long-pass filter, the use of a red bandpass filter was more effective passing the LED output while blocking all of the visible and near-infrared ambient light that CCD cameras are sensitive to. As a result, image contrast was greatly improved, and the variability associated with ambient light was effectively eliminated. This understanding led MidOpt to design a red bandpass filter that captures the output of the 660 nanometer LED lighting. The new design also took into account the wider fields of view imposed by smaller, shorter focal length machine vision lenses. These innovations, coupled with the simple and readily available mounting solutions, led to one of the most popular MidOpt products, the BP660. As machine vision technology evolved and LED lighting companies began to expand their range of available wavelengths, MidOpt responded by designing and stocking complementary bandpass filters. MidOpt would go on to add polarizing, protective windows, neutral density, and light balancing filters to their catalog as machine vision applications grew in number and complexity. The prevalence of 660 nanometer red LEDs used in imaging applications has now long passed. 625 to 635 nanometers is now the most popular red LED wavelength in use. Still, the BP660 and other similar MidOpt filters will continue to be an important part of their industry-leading offerings of machine vision filters, lenses, and related accessories.